Hello all, my name is Asriva from Civil ITP. Today, my presentation is on the topic of characteristics for batteries and elementary calculations for energy consumption. So, first of all, we have characteristics for batteries. There are five. First one is capacity of the battery, rate of discharge, temperature, density of the electrolyte, and shelf life. So, first, the capacity of the battery. It is defined as the product of current in amperes and the time in hours. It is measured in ampere hours. Mathematically, it is expressed as capacity is equals to I into T, where I is the current and T is the time. We can also define the capacity of battery as the measure of a battery's ability to store or deliver electrical energy. And next, we have rate of discharge. It refers to the amount of current a battery can discharge in a given span of time. Here we have the capacity of a battery is inversely proportional to the rate of discharge. So in the right side we have a graph where as the rate of discharge increases, the capacity of the also increases. That is capacity of the battery is it is inversely it is not increasing, that is inversely proportional. So the next we have temperature. The capacity of the battery is directly proportional to temperature. It is as the temperature increases, the capacity also increases. At low temperature, the voltage and capacity of the cell decreases rapidly, even in full charge conditions. Density of the electrode. So sorry. In temperature, we have two conditions. The first, in cold and in hot. The place where high temperature and in low temperature. At high temperature, the chemical reactions will be faster which gets accelerated, which leads to the faster degradation of the energy and uh, and a short lifespan. And then next, in cold conditions, that is where the temperature is lower, the chemical reaction gets slowed down, reducing battery capacity and leading to a temporary loss of power. Then next, density of the electrolyte. Capacity of the battery is directly related to the density of the electrolyte. In other words, increasing density of the electrolyte increases the capacity of the battery. That is, the density of the electrolyte is directly proportional to the capacity of the battery. Here we have seen two cases: at low temperature and at high temperature. In colder conditions, the higher density electrolyte must be used, and in the case where the temperature is higher, the outdoor temperature is higher, we must use the batteries of lower density and lower density of lower electrolyte lower density must be used. Then next, we have shelf life. So some batteries store current for many years without self-discharge of current. So it is necessary that a battery of good shelf life must be used. So when we do not use a battery for more than without using it, the power loss must not happen. So which is one of the characteristics of battery which plays a crucial role. Then next, let's move on to the second topic, which is elementary calculations for energy consumption. So we have here we will be calculating how many units of energy is consumed by multiplying the here in this kind of numericals will be the different appliances will be given and the wattage will be given and total hours which is consumed will be given. Where we will be calculating all the uh, total wattage and how much electricity will be produced at the end of the month. Yeah, so let's move on to the first one. First numerical. A house has the following loads: 5 lamps, 60 watts, each working for 6 hours a day; 4 lamps of 100 watts, each working for 5 hours a day; 2 heaters of 1000 watts, each working for 3 hours a day; 5 fans of 80 watts, each working for 12 hours a day. So we'll here the question is calculate the January bill if rate of charge is rupees 0.550 per unit, that is 50 paise, and rupees 10 as rent per month. So here, in this kind of numericals, we'll be forming a table which includes the load, that is the different appliances, and the wattage, which will be specified in the question for different appliances and the quantity, total wattage, working hours, and energy watt per day. Here we have two unknowns, which is the total wattage and energy watt per day. The total wattage can be calculated by multiplying the or else which can be obtained by the product of the quantity into wattage. Here, in the first case, we have lamps, which are which are in 5, and the wattage specified is 60 watts. So the total wattage will be 60 into 5, that is 300 watts. Then next, energy watt per day, which will be obtained by multiplying the total wattage into working hours, that is 2400 watt per day. Then next, we have lamps, which is of 100 watts. Since the appliance may be the same, but the wattage specified is different. So we'll be calculating we'll be calculating different total wattage as well as the energy watt per day. So we have lamps which is of 100 wattage and quantity specified is 4. So we will be getting the total wattage as 100 in the product of 100 into 4, which is 400, and energy watt per day, which is 400 into 5, which is 2000 watt per day. So 400 400 watts and 2000 watt hour per day. Heaters. The next, moving on to heaters. The wattage specified is 1000 watts and the quantity is 5. Sorry, the quantity is 2. So we will be getting the total wattage as the the product of 1000 into 2, that is 2000 watts, and energy watt hour per day, which is 2000 into 3, which is 6000 watt hour per day. Then next, moving on to fans, which is 80 watts. Quantity is 5. So the total wattage is 400 watts, and will be multiplying to obtain the energy watt hour per day. We'll be multiplying 400 into 12. That is 4000 watt hour per day. So after adding up all the appliances used in a day, we'll be getting 15.2 kilowatt hour per day. So we'll be calculating the number of units consumed in the month of January, total or else total energy consumed in the month of January, which is the product of 15.2, which we obtained by summing up all the uh, energy watt per day, and will be multiplying to the number of days, that is 31, which sums up which results as 471.2 kilowatt hour. Since in the question it is given that cost per unit is 50 paise, uh, here and the which is helpful in calculating the monthly bill. So, to obtain the monthly bill, so we'll be multiplying the total energy consumed into cost per unit. If the meter it is specified, we'll be adding it, or else if it is not specified, we will not include. So, to get the monthly bill, total number of kilowatt hour consumed into cost per unit plus meter run per month, which is 471.2 point kilowatt hour into 0.50, which is the cost per unit, plus 10, which is the meter run, which results up to 245.6 rupees. So the next, we have another numerical. Find the energy consumed in a house for the month of June if the load is 4 lamps of 100 watts, each working for 6 hours a day, and we have half HP single phase pump motor used for 4 hours a day, 2 heater of 1 kilowatt each, one used for 2 hours and other used for 1 hour a day. So we must calculate the amount of bill if the cost of energy per unit is 65 paise per unit. So we'll be forming a table as we have done in the previous numerical, and we'll be listing out all the appliances and their wattage, and we'll be calculating the total wattage. So for the first case, we have the lamps where the wattage specified is 100 and the quantity is 4, which results the total wattage as 100 into 4, that is 400. And for the case of lamp, energy watt per day will be 400 into 6, that is 2000 watt per day. Sorry, 2400 watt per day. Then next, in the second case, we have electric motor. Since in the question it is the the wattage is not specified in watts, but is specified in 0.5 HP. Here we have a small conversion where the 1 HP is equal to 746 watts. Since it is given that 0.5 HP of motor is used, so we'll be converting it into watts, which results 373 watts. The quantity is 1. So the total wattage will be 373 watts, and the energy watt hour per day, which will be equal to 1492 watt hour per day. So here we have two heaters. Since the working hours is different, we'll be calculating we'll be calculating differently. So in the first case, the heater one, the wattage is same and the quantity is also same, but working hours is different. So the total wattage for the heater one and heater two will be same, but the energy watt hour per day will be different. So after calculating all the energy watt hour per day, we'll be getting 6.892 kilowatt hour per day. So the total energy consumed in the house for the month of June is total energy consumed, that is 6.892 kilowatt into number of days, that is 3130, which gives 203.76. Since it is given the cost per unit is 0.65 paise, sorry, 65 paise, the amount of bill for the month of June is 65 into 203.76, which results 134.39. Thank you.